Hey students, this is Mr. Roberts. It's been a long week. We've learned about doing solving equations with addition and subtraction. We are now moving on to solving equations with multiplication and division. So if you look at your little card right here, this is where we're focused. We're looking at these two sections right here today. Okay, let's take a look at your bell work. All right, so here is your bell work for today, and this is the first question. It says the muffin batter contains 2 cups of flour, 1 cup of milk, and 1/2 cup of sugar, and 3 eggs. What is the ratio of flour to milk? So I'm just going to use my highlighter here, and I'm going to find the flour. The flour was 2 cups of flour, and the milk was 1 cup. So my ratio of flour to milk would have been 2 to 1. Okay, now it says what is the ratio of sugar to flour? So sugar, 1/2, oh whoops, wrong pen. So we have 1/2 cup of sugar. And the flour, we already know it's right here, isn't it? So we're gonna look at that. So we wanna look at the red stuff. And so sugar comes first. So how do we write a half? Well, you can write it as either this. Oh, I keep forgetting to flip that back. You can write it like this, 1/2 to 2, or 0.5 to 2. So either way that you want to do that works on that one. So there you go. Number 2, a rectangular prism has a volume of 864 cubic centimeters. The prism is 9 centimeters tall and 12 centimeters long. How wide is it? Okay, so if you remember the formula of finding volume for a 3D figure, a 3D rectangular prism is length times height times width equals volume. So we have the volume. It's 864. It looks like we have the height, which is tall, and long, that's length. So we have the 12 and we have the 9, and we don't know what the width is. So this is a great introduction to what we're actually doing today in solving equations. So what is 12 times 9? So find out what 12 times 9 is. It's 108. So we have 108 W equals 864. Well, this is multiplication. To undo the multiplication, we use division. So now that gets rid of everything, and it is W here. Because I divided by 108 here, I have to divide by 108 here. So we're going to take out that calculator and go 864 divided by 108, and we get 8. So the width is 8, and it looks like this is in centimeters. So we have width of 8 centimeters. Okay, so now it wants us to find the mean, median, mode, and range. So the first thing that I'm going to do whenever I get a set of data is I'm going to put that data in order from least to greatest. And it looks like I have nothing less than 80. So I'm going to go 80 and 80, because there's 2 of them. No 81s, no 82s. It looks like we have an 83 and an 84 and an 85. And an 87 would come next. Then it looks like we get into the 90s, and we have 91, 96, and a 97 being our largest percent. So now we can find out a lot of things here. We remember that the median is the middle number, so we might have to count here to see where the middle is. I'm going to count my numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be my fifth number. 1, 2, 3, 4, 5. There is my median. I can check that by going, there's 4 on this side, there's 4 on that side. So 85 is my median. My mode, what number happens the most? 80. My range, 97 minus 80 is 17. And my mean, we need to use our calculator. We are going to go 80 plus 80 plus 83 plus 84 plus 85 plus 87 plus 91 plus 96 plus 97. Hit enter, that's 783. And we're going to divide it by 9. And we get the mean of 87. Is this a good set of data? Well, our median was here, and our mean was right here. So yeah, we have some good data here that shows a good representation of a sample here. So anyway, there's your bell work. Let's move on. Okay, so yesterday we did things, and the day before we did things like this. 3 plus x equals 9. And you can remember that we used the railroad tracks. We subtracted 3 from both sides. That left x over here. Bring down my equal sign. Subtracted, and we get 6. Now we can plug that 6 back in for x, and 3 plus 6 equals 9. So that's how you do that question. So that's what we just got done doing. Now we use the inverse operations to do this, and we're going to continue using inverse operations. The only thing that's different is we're talking about multiplication and division. So let's take a look at this first question. We have 3x equals 27. So railroad track, we're going to still start there. Now, that says 3 times x. What is the inverse of timesing? Well, division. And why does this work? Mathematically, it works because what is 3 over 3? It's 1. And 1x is the same as just x. So that's what happens there. I know a lot of teachers say, oh, it just crosses out, and that's fine to say, but you really need to understand that, you know, when we were doing this, let's go back to that original question that we started out with today, that we had 3 plus x equals 9. Well, why does this inverse thing work here? Because when I do minus 3 here, it turns into 0. So what is 0 plus x? We have x. Well, this is a different property of mathematics here that we're talking about, that the 3 divided by 3 turns into 1, and 1 times x, and 1x is x. And just like we did over here where we subtracted 3 here, we're dividing by 3. So we're going to divide 27 by 3, and we get 9. Now, what is 3 times 9? We can plug this 9 back in for x. 3 times 9, it equals 27. So there we go. So you can kind of see that this is just almost the same thing. It's not identical because we're using a different property here, but it gets the same. I mean, we're basically using the railroad tracks, and we're using inverse operation to come up with the answer. So let's take a look at this one. Another one that's just like it. So you're going to go, all right, railroad track, that's multiplication. 4 times x is, the inverse is divide by 4. Those really turn into a 1, but we can say, oh, it just crosses out. That becomes x. 16 divided by 4 is 4. What is 4 times 4? 16. So we know that that is correct. Moving on. I don't know why my things aren't erasing today, but they aren't. So give me a moment. I'm sorry. Some of the things are sticking on my page, and some of them are being kind of crazy, and they're not doing what they're supposed to. Okay, now let's talk about division, because division is, if you analyze mathematically what's going on here, there is something a little bit different. We're still going to use the same strategy, though. So I have x divided by 8. Well, what's the inverse of dividing by 8? Well, it's multiplying by 8. So if I'm going to multiply this by 8, Okay, what's really happening? Well, if we're multiplying by 8, it really mathematically looks like that. We get 8x over 8. And just like with multiplication, we got a 1 there. 8 over 8 is 1, which turns into x. So that is really what's happening here. So because I multiplied by 8 here, I'm going to multiply this side by 8, and I get 16. Now, I can plug that 16 back in for x. 16 divided by 8 equals 2. I know I did it right. Okay, let's do one more of these, and then we'll look at your practice. Oh boy, again, my stuff is not doing what I want. So let's see if I can just delete it. Goodbye. Yeah, that worked great. Okay, so here we go. One more. Okay, we're going to start off with our railroad track. That says a number x divided by 5. Well, the inverse operation is times by 5. You can take a little shortcut here. You don't have to do the one thing. You can just say, oh, I'm timesing by 5, so those cross out. And that becomes an x. 10 divided by 5 is 2. Oh, do you know what I did wrong? Did you catch what Mr. Roberts did wrong? This is multiply, not divide. So we need to go backwards a little bit, don't we? We need to times this by 5. And we get 50. So you have to be careful what you're doing. Because we timesed by 5 here, we have to times by 5 on the other side. And then this answer, whenever we plug it back in, should give me the answer that we have over here. So 50 divided by 5. Is it 10? It certainly is. So we know that we have that correct. All right, let's take a look at your practice. Okay, so here is your practice, and we're going to be solving these equations using the railroad tracks, just like we did on the notes. So here we go, railroad track at the equal sign. 7 times k. What is the inverse of multiplication or timesing? It's dividing. We're left with k. Because we divided by 7 here, we're going to divide by 7 here, and we get 11. All right, let's take a look at number 2 now. Number 2, we are going to do the same thing, inverse operation, start with our railroad track. P divided by 5. Well, what is the inverse of dividing by 5? It's multiplying by 5. Those are gone. We're left with P. We timesed by 5 there, so we're going to times by 5 here, and we get 50. And I think that question right there is almost identical to the one we did in our notes. All right, let's see what's next here. It looks like number 3. Do we have to freak out if the variable is on the other side? No, we don't have to freak out about that. All we have to do is just go, okay, m divided by 12. What's the inverse operation of dividing by 12? We're going to times by 12. Goodbye, 12s, left with m. Over here, we're going to times by 12, and we get 36. Now, I've said this before. 36 equals m is the same as m equals 36. So no matter what way you write it, it's still correct. You can write it whichever way you want, but that is I just want you to understand, if we flip them, that it doesn't matter. It doesn't change the value. All right, so let's see. Number 4. I'm going to actually hit pause on this one. I want you to hit pause and try this on your own. So go ahead, try it out. Okay, did you get A equals 9? If you did, you did it correctly. If you didn't, let's pay a little bit more close attention and see if we can get some of these other ones correct. Okay, so now we have one. Then I don't want anybody to be confused here. We threw that little dot in there, didn't we? That dot means multiply. So that says 5 times x. So we're just going to divide by 5, and that all leaves. And we're left with x. 12 divided by 5? Can that happen? Yeah, it can. We know that we're going to get a decimal on this one, and sometimes our answers are decimals, but we can always check it to see if if we get it right. So 12 divided by 5 is 2.4. Now let's see if this works. If I put 2.4 back into this x. So 5 times 2.4. 5 times 2.4 in my calculator. What did I get? I got 12. So I know without a doubt that this is correct. So if you ever are in question of whether your answer is correct, just plug it back into the original equation and it will tell you if you got it right or if you got it wrong. Now again, decimals and fractions, you're going to run into those things. And you don't have to panic. You just do the same thing that we always do. Railroad track, C divided by 8. Well, we're going to times by 8. Goodbye. This becomes a C. Bring down my equal sign. Because I timesed by 8 here, I must times by 8 here. And I'm going to use my calculator for this and go 8 times 4.2, and I get 33.6. Now, it's kind of hard to see if that really is the answer, but we can always plug it back into this variable. So this, plug it in, use substitution. So I'm going to go 33.6 divided by 8, and guess what I get? I got 4.2. So I know without a doubt that this is the solution to this equation. All right, so let's take a look at some word problems here. You earn $5 for every friendship bracelet you sell. Write and solve an equation to find the number of bracelets you have to sell to earn $85. Okay, so this is a multiplication problem. We're going to be going 5, and we'll call it B for bracelet. So 5B equals 85. That looks very similar to what we've been doing, doesn't it? So we're going to divide by 5, left with B. 85 divided by 5. And we get 17. We have to sell 17 bracelets to get $85. All right, number 8. You practice the piano for 30 minutes a day. Write and solve an equation to find the total time, T, you spend practicing the piano in a week. So on this one, again, writing equations from sentences can be a challenge sometimes, but if one way doesn't work, you can always flip places with the variable and try different methods if you need to. You know, trial and error. So on this one, I know that I have the time, so we're gonna start out with the T. And I know that this is a week, so it's 7 days. So I know it's gonna be the time divided by 7 is gonna equal 30. Okay, so here we go. Let's see if this works. See if it's a reasonable answer. So I'm gonna times by 7 here, and I get T, because that's what I'm really trying to find is the time. And I'm going to times by 7 here, so it's 210 minutes. Now, let's see if that works. If I take 210 and divide it by 7, is it 30? It certainly is. So I know that this is the correct answer. All right, guys, let's take a look at your assignment now. Okay, so looking at your assignment, it looks like we have some equations that we're just going to solve. Again, refer to the practice in the video if you need to see how to do this. This one right here, we didn't see any questions like this, but I think it's pretty self-explanatory. We got to see if this guy made the right choice or not. And by the way, I know it's kind of hard to see what this is, so if you want to write x equals 3 at the bottom of your page, that's what that says. That'll help you. Now, right here it says write an equation for each shape. Well, you guys should know how to find the area of or write an equation for these, okay? So I'm gonna just help you out a little bit. So on this one, we're gonna go base times height equals area. Okay, this one is base times height divided by 2 equals area. So you're just gonna use substitution and then solve for it. It gives you the area up here. And then for this last one, a parallelogram. Actually, let's see if I want to, I think I want to do with this one with you in class. So let's just skip this parallelogram problem. and I will just give you the solution to that one, and we'll discuss that actually. All right, guys, good luck on this. If you need help, ask your teacher. Refer to the videos that are in GoFormative. Those are there for to help you, and you can also ask your teacher for help. Good luck, until next time.